Hi everyone, this is a hard space-time diagram IB past paper question, and we're going to move on straight to solving the question, so pause the video and read the question if you need to. Alright, so we know the first question is asking for the CT primed axis, and we know the CT primed axis is going to look something like this. And this theta here, the angle between CT axis and the CT prime axis, and the x primed axis and the x axis is going to be the same. Now I got my protractor and measured that this was about 26 degrees, so this is going to be 26 degrees. Alright, keeping that in mind, I'm going to use my ruler, rotate it 26 degrees. Okay, that's my x primed axis. So that's the first question done. Now draw on the graph the path of light emitted from the match to show the events where the light strikes both mirrors. So this is the event where the light is struck from a match. And so photons will be emitted, right? And photons will be emitted to both directions. Let's say this is the train, this is the match. Photons are going to be emitted front, back, to the front and the back. So we need to draw two separate world lines for the photons. For light, because it splits into two, it's going two different directions. So we can't just suffice with one light world line. We need two. So we know that the light world line has to be 45 degrees from the CT axis. So I'm going to set my ruler to 45 degrees. And from this event, the light is being emitted from the event, not the origin. So I'm going to shift my ruler here, draw a 45 degrees line from the event. So got this line. That's our photons that are going, that's the world line of the light that's moving to the front of the train. And now we're gonna set our angles to 45 degrees the other way, so 135 degrees. Again, shift the ruler so we start from our event E. And that's the world line of the light going to the back of the train. 45 degrees, 45 degrees. Okay, and now they say that label the path of the light, show the events where the light strikes both mirrors, label the events TB and TF. Okay, so this light here is going to the back of the train, so it strikes the back mirror. This is TB. On the other hand, this is TF. Okay, that's this question done. And now let's say, and it says, explain with reference to TB and TF, which person concludes that the light reached both mirrors simultaneously. So because this is 2 marks, we know that the question wants us to use the space-time diagram to find this out. But if you just use your common sense, the person in the train is going to observe that light hits both mirrors simultaneously. Just like how when you're in a room and you turn on a match and you have mirrors that are equidistant from you but opposite directions, you expect the light to hit them at the same time, right? Although basically you are moving because the Earth's rotating and around its axis and around the sun. So that's the same logic you should apply to this moving observer. From this observer within the trains, from their perspective, they're stationary. Therefore, the same normal, quote-unquote normal rules of physics apply. And so that's basically the conclusion that we expect to draw. And we're gonna use a space-time diagram to draw this conclusion. So because we think that the moving observer is gonna see these two events as simultaneous, aka happening in the same time, we're gonna match our ruler's angle to the x primed axis, and then we're gonna bring this ruler up to each of our events, and we're gonna draw a dashed line connecting the point of the events to the CT primed axis. And then we're gonna do the same thing for TF. And wow, we see that these two lines, they coincide on one point on the CT primed axis. Let's call this T. So we can tell that by the space-time diagram, both events TF and TB happen simultaneously for the moving observer. So we're going to say moving observer. This is because both events TB and TF occur at the same time on the CT prime axes. I have labeled this as T. Thus, to the moving observer, TB and TF occur simultaneously. Let's check the mark scheme. Let's see what it says. Now the mark scheme says line joining TB and TF is parallel to x-axis, so identify the same coordinate. Okay, so you have to very sort of explicitly mention that the line that, like, remember when I just set the angle of the ruler to the x primed axis and I shifted it up to find the line, to draw a line from each of the events to its intersection on the CT primed axis? I think you have to write that down. So line connecting TB and TF is parallel to x primed axes. Is that it? Yeah, then you get 2 marks. What I wrote initially will only get you 1 mark. State the length of the train for the observer to the ground. Okay. So from the perspective of the moving observer, let's call this person Alex. Alex here. Basically, this is gonna be the length of the train. It's just the distance from the back mirror to the front mirror. So whatever this is the length of the train from his perspective. But we're trying to find the length of the train from the observer on the ground. And if you watch one of my space-time diagrams, you will hear me say how you find length contraction is you draw a line, you set your ruler to perpendicular to the CT primed axes, you move your ruler to the event, and you mark this parallel lines intersect with the normal x-axis. So we got here, and at the same time, we got here. So this is the x from the stationary observer's perspective. This is the position of the back of the train, and this is the position of the front of the train. And we have 3 big boxes here, 3 big boxes here. And so the front is 3 meters away from origin, the back is 3 meters away from the origin, -3 meters away from the origin, and therefore the train is 6 meters long from the observers in the ground.